we look at this problem, you guys, a lot of people start out by saying, okay, they want to know how fast it's going when it reaches the bottom of the ramp. Well, cross that bridge later. You can't find that. Forces only tell you a force or an acceleration. That's all they can tell you. So if the problem is out of the force chapter and they're asking for velocity, well, you're not going to find it from forces. And this is actually the easy part. Because it's in the force chapter, you kind of know it's going to be a Newton's second law problem. I'm saying that because when you get the AP exam, it's not like they say, okay guys, this is the force question. They say, here, use physics to solve this problem. Do you catch my meaning? You can't find velocity from forces. You can find acceleration from forces. And with acceleration and knowing the block started at an initial velocity of 0 and is sliding down a ramp that is L long, you could probably find the final velocity using some other method. Maybe there's a reason this particular chapter comes after kinematics. You take my meaning? So we're not going to find the velocity of the box at the bottom. Not straight away. We are going to be able to find it after we know the acceleration. Forces can only tell us acceleration. First thing I said when we started talking about this stuff. So we can find the acceleration, but they didn't give us the angle. Look, everything we've been doing in here, when it comes to an inclined plane, assume that we have the angle. So start with the angle. It's an inclined plane. It has an angle. I mean, is it a ramp? If it's a ramp, there's an angle. Now, you might not be able to use it in your answer, but don't start your problem thinking that you have to start with the things they give you. If it's a ramp, you know it has an angle. You've been using the angle the entire time. Don't all of a sudden decide that you have to figure out this problem without the angle. So start with an angle. There's definitely an angle there. Now, I don't want to spend too much time. We should have known from yesterday that what the acceleration is. What I mean by that is it's every single ramp problem with friction is going to have the exact same answer. It's going to be g sine theta minus mu g cosine theta. Every single one will be like this. Now, we're going to go through it. I'm not going to say that you should memorize that, because that's probably the wrong thing to do. But when it comes to the forces here, those forces are always going to be resolved exactly the same. Now, we could change it. They could throw something at you. But ultimately, you're still going to break this up into forces that are directed down the ramp because it's accelerating down the ramp. And if that's what you're going to do, the forces you're going to have are all going to work out the same way every time. So, considering all of that, and considering I didn't leave myself a whole lot of space, mg, normal, friction. Any question there? All right, I'm thinking coordinate system like this. Something that's lined up with the ramp. That make good sense? This is theta right there. So now I need to break up the one force that is off axis, meaning I have to find a way of expressing mg in terms of its components. Now this is what stops all the students who are new to physics. This is where you guys run into difficulty. But when looking at this problem, I want to remind you that if you line up your coordinates with the ramp, you could memorize these two components, mg cosine theta and mg sine theta. You could memorize them. I mean, I would know how to do it. But once you feel relatively confident in knowing how to do it, I'd break it up the same way every time. Unless you have good cause not to. And we're going to see reasons not to in the future. Times when it might not be best to do this. A car driving on a banked curve, for one. It's not best to do it this way. but in this example it is, especially because this block slides down the ramp and accelerates down the ramp. We always give the priority to the direction of the acceleration. So, with that being said, our whole goal, and I've tried to boldface type this, is to break our problem up into one-dimensional problems with arrows that point just in the x direction or just in the y direction. You have to get there. It's the only type of math you know. And in this example, the net force in the x direction is the direction of the acceleration. And there are two forces in the x direction. mg sine theta is pulling the block down the ramp. Friction is trying to slow it. Together, they give us an acceleration. There you go. That's physics. That's all the physics tells us, is that. So, y direction, there's a little more physics. That's got to be 0. And what I'm saying is that the box isn't accelerating up or down relative to the ramp. So those have to be balanced. It never hovers above the ramp. It never burrows into the ramp. So those have to be balanced. And there's two. There's the normal force from the ramp minus the part of the weight that is into the ramp. That has to be 0. Now again, this, physics. Newton's laws got us that. Now there is more. I mean, looking at this, they wouldn't have given us the coefficient if they didn't expect us to use it. At least I would hope so. But more importantly, as I start to look at what they gave us, it seems unlikely I'd be allowed to express my answer in terms of the frictional force. Now when they gave us the coefficient of friction, that's them suggesting F can't be in my answer. Now this has nothing to do with physics. This is AP for right now. They're going to give you a list of which variables can be in your answer. And if you have a variable in your equation that's not in the list, you've got work to do. But it's not physics work, it's algebra. Now I will agree, knowing that friction equals mu times the normal force, that's probably physics, I guess. Because this is how we're going to get rid of the frictional force in that equation. So that's where we're going to go now. We're going to do some substitution and get mg sine theta minus mu times the normal force equals ma. But now, really all I've done is exchanged one problem for another problem. Because yes, I got rid of the lowercase f, but then I got an uppercase N. Normal force is probably not going to be allowed in my answer, especially a responsive force like this that can change depending on the angle. So I'm pretty sure that's got to go too. Do I have a way of eliminating it? Sure. That's why we did the work in the y direction. It gives me something that's related back to the ramp. Now, the reason why I think some of you are missing the points on these, or missing the idea, is when I get this all the way written, I want you to notice that this relationship only has things in it that are physical parts of the ramp. Do you guys notice that? There's no expression for variable forces that may or may not exist. I got the mass of the block, I got the coefficient of friction, the angle of the ramp. That's in this equation. All the physical parts of the system are here. That's the goal, is to try and figure out how the system behaves based on things that you could touch and hold. Can you touch or hold the normal force? The answer is no, which is why you wouldn't have that in your answer. Can you touch or hold the friction force? No, you wouldn't have that in your answer. I can measure the mass. I can measure the angle. I can look up mu on a table. If I want an answer, this is an answer. This tells me the net force. This tells me the acceleration. That's truly the answer. And then, of course, through some quirk of the universe, something that I think is actually an interesting discussion of physics that we completely neglect, the mass apparently has nothing to do with this. That's a quirk of the universe, to be honest with you. That canceling out the mass right there seems like just an algebra step, but it's telling us that the part of mass that causes gravity is the same thing that causes inertia. That's a weird part of physics. That would be a neat discussion. But that's not, our class isn't about neat discussions. It's about just, boring, horrible algebra, which is what we have here. And I do want to notice that that's what you get, right? It's not a surprise. It's going to be that way every single time a block slides down a ramp. Now, here's the issue. Even if I write this over here and say, okay, so it's a g sine theta minus mu g cosine theta, that's great, but theta can't be in your answer. So, what do? Remember I said, I expect you to know things. Everything here is something that you've done already. This is a rehash of a problem we've done. If you can repeat this part, you've done the physics. What do you think the problem's going to look like on the AP exam? Draw a free body diagram, get a couple 3 points for that. Set up a force equation, solve for the acceleration. They're probably going to give points for knowing that the normal force equals mg cosine theta. There's probably going to be a point for getting that the acceleration is related to both g sine theta and mu g cosine theta. If you can't do this, I expect you to know things. And I'm not asking for much here. I'm asking for like the definition of like trig. But I'm a teacher, barely. I'm not sure how much teaching I do anymore. I think I'm teaching, but I'm not sure if I am. It's probably time for a new line of work. I think pole dancer might be in my future. Yeah, I've been hitting the gym. I've been working out. All right, so I'm looking at this. You're wondering what you're going to do. You're not allowed to have theta, but they did give us the height and the length. Right? Yeah. So when I say I'm expecting you to know things, this isn't obvious. And look, if this was an AP question, Off by one variable, mastering physics will just basically cut you to shreds, right?
Yeah.
So v squared equals 2, all right, A, remember that was G over L times H minus mu times the square root of L squared minus H squared. And I'll point out I am doing all this from memory. I'm not looking back on my prior page. Come on, bring something to the table, guys. Do you notice, though, that I have an L in the denominator here and an L in the numerator there? I mean, everything in this parentheses is just a number, so I should be able to cancel those two L's out. So, because I do know algebra, in fact, I'm darn tootin' good at it, 2G H minus mu times the square root of L squared minus H squared. How are we doing? Sure. I'm going to do something else. I'm going to show you something. I'm going to go ahead and distribute the 2G. There. That's your answer. Yeah, you take the square root of it. But I do want to point out that when you take the square root of this, and I'm going to take the square root now by erasing that and drawing a square root, so I get a square root of a square root. Boy, that looks beautiful. Square root of 2gh. Right? How fast something's going if you drop it a distance h. You see it right there, don't you? So if there was no friction, it would be going as fast as if you just dropped it from the top of the incline. You know what else is kind of interesting? I mean, I don't know if you'll find this interesting, but do you realize that this is the horizontal distance along the ground? So this would be the work done by friction for all of you who had physics last year. Because this is the frictional force. So I take how fast it would be going if there was no friction, and I subtract how much of the energy is taken away by friction. This problem could have been solved in about 3 lines using energy, but apparently 3 pages using forces. So if you're actually presented with this problem on the AP exam, this might not be the best way to solve it. We'll see this problem again in about a month, where we'll solve it in about 3 lines instead of forces, which, as I said from the very beginning, is the absolute hardest way to solve a problem. If you can find a way around it, you should do so. All right, so I have a forklift. I got a 300 kilogram box rest on a platform attached to a forklift shown above. Starting from rest at time equals 0, the box is lowered with a downward acceleration of 1.5 meters per second squared. Wow, this one gave you numbers. Let's put that in the back of my mind for a minute. Determine the upward force exerted by the horizontal platform on the box as it is lowered. Well, the box must be experiencing a normal force, and it has its own weight, and I think the weight must be greater than the normal force because it's accelerating downwards. By the way, this is the elevator problem. Right? It's the same as the elevator problem. And the elevator problem is supposed to demonstrate to you that an object that is accelerated downwards has an unbalanced force that is likely going to be its weight greater than whatever is supporting it. That was the goal of teaching the elevator problem. In this case, it's a one-dimensional problem. The normal force is not pushing upwards as hard as the weight is pushing downwards. The weight, by the way, is 3,000 newtons because it's 300 kilograms. Can I go on? Okay, we are interested in the normal force. It says specifically, determine the upward force exerted by the horizontal platform on the box. We know that net force equals ma because the system is accelerating. Now, I'm going to pause for a minute. There are 2 forces. I am going to set downwards as positive. There's no reason not to, and upwards is negative. And I'll have 3,000 minus normal force equals 300 times A. Any question at all about that? I need the normal force by itself. The normal force by itself is going to be 3,000 minus 450. So the normal force is going to be 2550 newtons. Good job, Alejandro. You got the right answer. This is the upward force from the platform. I'd argue that this is probably low-hanging fruit, right? You've heard that phrase before. These are the easy ones to pick. So I don't think you'd expect to get too many points for this. On a 15-point problem, we're probably looking at 2 points for this. Maybe 3, but I think 3 would be a gift. That was part A. Part B. At time t equals 0, the forklift also begins to move forward with an acceleration of 2 meters per second squared, while lowering the box as described above. The box does not slip or tip over. Determine the frictional force on the box. Well, looking back at my free body diagram, the only force pushing the box to the right is the frictional force on the box. There is nothing else pushing the box to the right. That would be hard to come up with the first time you see it. So for you guys who are new to physics, that would probably be a bit of a curve. You'd want that information. But is there anything else that's causing the box to move forward? This would be you holding a book in your hand and then starting to walk forward. The only thing that would be causing the book to move forward would be friction. If you move too fast, you'll break friction. Friction has a limit as to how much force it can apply. In this problem, though, they say determine the frictional force on the box. It's the only one in the x direction. So the net force in the x direction has to equal ma. Friction is the only force in the x direction. So the frictional force has to be 600 newtons. Box accelerates 2 meters per second squared forwards, has a mass of 300. That has to be the frictional force. Given that the box does not slip, determine the minimum possible coefficient of friction between the box and the platform. All right? I mean, I just solved for the normal force, and I just solved for the frictional force. Solving for the coefficient isn't going to be a challenge, because friction is the ratio. All right? Preserving my inequality there, I'll have 600 divided by 2550. And the coefficient of friction is a unitless quantity. Alejandro says it's 0.24. I think he's right. You guys think he's right? I assume 600 divided by 2550 was within his calculating abilities. Look, if you got to here, you passed the AP exam. Man, this has got to be enough points to pass. Probably pass with a 3, though. I think the next parts are going to be what really tests you, but I don't know. In a few minutes, we'll look at the we can look at the grading guidelines. But this is all the physics that we have. Believe it or not, what we do next isn't very much physics. Bro, are there any questions about this? Okay. Determine the equation for the path of the box that expresses y as a function of x. Anybody do this? Aw, that hits me in the feels just a little bit. This is so much not harder. This is not as hard as you think it is. And I'll show you. And when I do, if you want to cry a little bit, because it's not as hard as you thought, I'll be happy to see those tears. Let's think in the y direction what's happening. Okay? Delta y, vy naught, vy, a, and t. In the y direction, remember I need to have y as a function of x, but I can only get a parametric equation of y as a function of t. Because this thing is accelerating at a constant, so I can use motion equations. The acceleration is 1.5 meters per second squared downwards with an initial velocity of 0, giving me a delta y of 1/2 times 1.5 t squared. In the x direction, I have initial velocity of 0 and acceleration of 2. If I want to put together an equation for where it is, it's delta x equals 1/2 times 2 t squared. You guys see that okay? Well, I can solve one of these for t squared and set it equal to the other, and right now delta x equals t squared. So delta y equals 1/2 of 1.5 is 0.75 delta x. That's it. No, we did it much harder when we had to do the projectile. Remember with the projectile we came up with this trajectory? It was that complicated thing with tangent in it. This is the same thing. What it's going to look like on the chart is going to be a straight line with a slope of 0.75. It had nothing to do with physics, though. It's just algebra.